Elevator So Simon was my name. Worked at RWTH Aachen, led the electromobility laboratory there, and last year started an own engineering consultancy. And besides my consulting work on the technical end, I am also doing the battery expedition and basically showing off the competence that European innovators deliver for the European battery ecosystem through this expedition. You can find out more on LinkedIn. So Max, the stage is yours.
Perfect. Yes. And with this, I welcome again everybody who is joining today. Thank you very much. My name is Maximilian Wagner. I'm the manager of the TraWeBa network. The TraWeBa network is focused on connecting companies, supporting the companies along the battery value chain in Germany, also connecting the German companies with Europe, and therefore build and strengthen the European battery ecosystem. I think that is also enough for the overview what we are doing. You can, of course, find more about us as well on LinkedIn, on our website, where we will share the recordings of today's event as well. So if you know somebody who wanted to attend but couldn't make it, just send them the website. We will send it around by email as well, so he can watch all the pitches he wants as well. And I think with this, we move over to our first speaker, and I'm very pleased to introduce Sarah Colbourn today as our starting picture. She is working at Benchmark Mineral Intelligence. And
thank you very much, Max, and hi everyone. Nice to meet you. As Max said, I'm Sarah, and I head up the sustainability team at Benchmark. With the 4 minutes in mind, I'll jump kind of straight into what I'm here to talk about today, and then I can always kind of talk more around myself and Benchmark in the 4 minutes following that. So we can come back to this, but to kind of kick things off, and like you say, Max, to set the scene of today's webinar, I just wanted to start with an overview of kind of where we're at in terms of battery cell demand and where we see things going. So no surprise in that we're expecting significant growth in global cell demand over the coming decade. Here, looking at that projected growth, and also looking at it by end use market. So really what we see is from 2025 to 2035, we're forecasting an over fourfold growth in battery demand, with the majority of that deriving from the EV market. However, we're seeing increasing proportions of demand from battery energy storage systems as well. We're seeing China representing significant portions of this demand, though Europe also, of course, increasingly representing significant proportions itself as well. But really, I think when we start to dig into this story of the supply chain and what it means, and from that perspective, what that really means is the growth in demand downstream is being felt upstream, particularly, as we say, around those critical minerals. So here I've just focused on some of the key cathode materials, looking at lithium, nickel, and cobalt market balances from today out to 2040. And of course, in order to meet the demand at cell level, we need to be feeding these plants with the materials needed. Hence why I thought this is just a very useful visualization to understand what this means for the upstream. And so what we can see across these markets is that within the next decade, a bit closer for some of the materials, slightly further away for some of the others, is that we will be seeing clear calls for additional material in order to meet this battery demand. And what we really see here is that mining will be a bottleneck for meeting demand at battery level. Of course, here, just for kind of context, I suppose, these the numbers that I'm presenting are taking into consideration new sources of supply, whether that be regionally or indeed new technologies. And crucially, it's also including what we're forecasting as secondary supply, so the materials recovered from recycling. And to dig into recycling in a bit more detail, particularly in the European context, what we can see is that recycling is increasingly going to become an opportunity for Europe. So on the left-hand side here, I've got a chart looking at forecast growth in battery recycling feedstock within Europe for today in 2025 and in 2035. So this is in gigawatt hours, but ultimately what we see here is that in the next 10 years, we're expecting an over 12 times growth in this pool. signifying that opportunity for the region. So that's an opportunity to move towards a more circular economy, strengthen supply independence, and of course, retain economic value from these materials. Really, though, when we look at that significant growth in feedstock, what we're also looking at is a significant investment required to really be able to meet the demand of this material being recycled, put back into cathode materials suitable for going back into the supply chain. And so one other chart that I really wanted to show here was kind of speaking to some of the complexity there. So this chart is looking at the market balance for European recycling capacity in terms of pre-treatment capacity, which is essentially taking in end-of-life batteries and production scrap and converting it to an intermediate product such as black mass, and then the refining capacity, so feeding in that black mass and producing battery materials. And so what we see is that in Europe at the moment, we are at an overcapacity in terms of pre-treatment, but really lacking in that refining capacity. So feeding plants with black mass and producing battery materials. And so as a result, a lot of that black mass is leaking out of the region and flowing towards Asia. This year, we have seen steps by the European government to kind of use policies and means to address this issue. However, we are still seeing this kind of trend carrying on. So I'm aware that that was a quick 4 minutes, but something to kind of set the scene in terms of understanding where we're at in terms of demand, where we're at critically with the critical materials and the recycling side of things. It's always something I find particularly interesting. But with that, I'll come back to the group and hopefully we can embark on a 4-minute discussion. Thank you.
Thank you very much and nicely on time. So are there already questions from the audience? Just the best way is to raise your hand or just unmute your microphone and ask your question. Otherwise, let me start with the first question. If you take into account what you showed us, and if you take into account though, if we would recycle everything we have in Europe, is there still like a material which is most critical, or we might not be able to cover with like recycling at all?
Yeah, it's a great question. So the way that we're kind of looking at recycling and therefore secondary supply in our models is we look at the volume of kind of EVs and portables and all the batteries that are deployed to market today. We apply a series of assumptions around, their lifespan, what proportion of them could go into secondary kind of applications, so into the reuse market, which is a whole other thing, which is really interesting. And so we apply those assumptions, we look at collection rates, which is a huge kind of part of the logistics conversation around the recycling market. And what we have calculated, kind of best case scenario in 2040, so still quite a long time away, around a quarter of lithium demand and about a third of lithium and cobalt demand could be met by recycling. Now, that's kind of a base case. There's a more optimistic outlook. There's a slightly more pessimistic outlook. But I think really what it demonstrates is that recycling is definitely something we should be doing. There are targets in terms of policy targets to be met. And from a circularity perspective, it's absolutely fundamental. And it also can help meet the supply needs. However, the reality is that we are going to have to be mining for the foreseeable to kind of get to the stage where there's enough material out of the ground to recycle further down the line.
Thank you very much. I don't see a question from the audience, so maybe let me continue with a short last question, well, because we already reached our time limit. What's your call of action? Like, what are you looking for?
In terms of in the battery space, I think there would be a lot of kind of different calls to action. So my specific role at Benchmark is to head up our sustainability research. That's where we're looking at all stages of the battery supply chain from mine to grid. And a key part of this is engaging with stakeholders that sit all around the supply chain at different stages with different perspectives to really understand kind of the key environment, social and governance risks and opportunities that are specific to different materials and different markets. And speaking to those stakeholders is a really kind of key part of our methodology that informs the data and intelligence that we produce. So I think one call from me would be, if you have a perspective that you'd like to share when it comes to the sustainability and kind of social side of what we're all working on within the battery supply chain, please do reach out, and I'd love to kind of involve you in some of those stakeholder conversations.
Great. Thank you.
Important. And my topic today is trying to share some of the best practice that we came out to work and support our European partners, local projects in building and designing their first cells ever in different scales and making homegrown European cells being successful. And my topic's design and process. A little bit about myself before I get started. So I'm Luke. I co-founded Electroder back in 2019, based on a decade of experience in battery cell design and manufacturing. And as Simon mentioned, over the ways we were getting a chance to build a digital tool that to improve the process from just purely trial and error. That's how we, why we built the company in the beginning. And and it's not just about not a sales pitch. But I'm also sitting in a steering committee of Global Battery Alliance, Battery Passport and Security Critical Mineral Steering Committee. I highly encourage you to look into Global Battery Alliance. It's kind of a very good mission in building sustainable value chains. Before I go to my topic about EU battery manufacturing, I want to make a great statement for many of you who have known me. I've always been an advocate of Europe need this cell manufacturer, and I think it's going to be possible. It's going to be successful. Although that we're talking about in reality, there are things happening. Some of my topic in the next couple of slides. I want to make it very clear that we need to be confident, we need to be resilient, and we need to be very, very sure that this is gonna work. And I take the opportunity to thank all the ones who have been, putting together an effort in this. So this is the map that showed back in 2021 by BatteryNews.de and about the cell manufacturing project in Europe at that time. And many, 4 years has passed, and let's look back what were the projects and where they are today. And I try to update it. And I hate to use the word of fail, but if the project is started, it's not going anywhere. It's just failed. There are new projects coming up, but there's still a sad thing that seeing what's in front of us. That we had ambition, we have been putting a lot of money, we have putting a lot of effort. Many people have put in their career in it, and it's not coming out the results. And we need to make it work. And a couple of months ago, Nicholas Tangent, CEO of Northern Bank Investments, interviewed Robin Zeng, who is the chairman of CATL, the largest cell manufacturer in the world at this moment. And he asked a question, why that many cell manufacturing projects in Europe has failed. And surprisingly, Robin said something that I had been trying to tell the communities many, many years ago, but of course, Robin has a bigger voice there, right? As he owns 40% of the market in the world. He said, the first thing is because of the wrong design. That's very surprising to many because, and we know that, and I'll explain why the design is so important. And secondly is the wrong process. So the thirdly, of course, also equally important, but putting the third is the wrong equipment. But you can see that design and process are kind of a determining factor in the quality of making cell manufacturing successful in the eyes of the largest cell manufacturer in the world. And cell design is critical because, to very obvious reason is the cell design serves a purpose in different application. And we are facing today, then 12 years ago, we were started in the industry doing commercial designs, is that we're facing many different applications, and each of them is asking for different perspective of cell, and they're different. And so because of that, the design is different, the structure is different, the recipe is different, and the process is different. So not a single cell manufacturing project is the same. So if we take approach of copy and paste from Asia, it's not going to work. And if you're trying to bring and reinvent the wheel, it's also not going to work. So what would be the best approach? So first, I think, the one we need to have is a solid cell design. I've seen and participated and trying to crack in some of the European projects is going there and seeing that it doesn't take quite a lot of efforts between the project getting money and they place an order to the equipment suppliers. And sometimes even worse is they will let equipment suppliers to do a blues design, to a cell design for them. And you can imagine when the equipment supplier is trying to bidding for €1 billion projects, and you ask, can you do this? Can you do that? Can you do that? And their answer will be yes and yes and yes, right? So, and then when it got FAT and SAT will face that, okay, that design is not serve purpose. The equipment's not in the boundary. And I found out that's a lot of impractical. There's a lot of things in that. And we need to have a solid design from electrical perspective and as well from cell design perspective, from cell assembly perspective. And then after that,
Luke, 1 minute.
We need to have a solid process. The process is service purpose to building a good product. So again, here is you cannot copy from anywhere because everyone is facing a different conditions in their plant. And some are starting from totally clean sheet, and some are starting from equipment process they're familiar with. And especially in Europe, we need to work on CE, we need to work on the local code and other things. So this is the other part, the process that we develop need to serve the purpose to building the cells eventually. That's because that's eventually we want to build it and produce the cells at high yield rate and high speed. Last but not least, coming to scaling. I think Europe is second to no other places to know how to develop and build cells. What we need to face is we need to make mass produce scalable production works. And that's where the first design and process will lay down a good foundation. If we don't have the good foundation, it's really hard to ramping up and scale. Okay, and last but not least, I'm closing my presentation today that by introducing that I'm working with Professor Li in Tsinghua University, also a visiting scholar in art application in the past, to work on a book for European and global battery industry. Is we're going to write publish with Lili next year on lithium-ion battery cells and focus on design and manufacturing. And I want to close that. Thank you again for together. Let's show resilience, bring know-how, and remain confident to make European battery cell manufacturing possible and working. Thank you.
Thank you, Luke. Thank you very much for this brief insights. I know this talk could go for 2 hours because there's a lot of know-how between every slide that you just showed. To the audience, is there a question up front? I'm looking in the chat right now. 1 second. I don't think so. No, not yet. So let me ask one question because we're a little bit behind time. And that is, how do you see the role of AI in this whole development of new battery technology from the product side and the production side? Do you think it will be a game changer, as many said, or do you also see stumbling stones where you think like good old organic knowledge from the brain and analytical models are still worthwhile and expertise? So can you just give us an estimation there with one quick answer, if that is possible?
Thank you. That's a really good question. In the industry, I'm seeing artificial intelligence currently playing 3 roles in 3 steps in the battery cell production perspective, the development and production. The first is AI has been introducing in developing materials, not only just in battery industry, but in medicine and pharmaceutical. It's coming into developing electrolyte. A lot of them is in high through output calculation as a small level. I think that's where AI is currently being deployed the most. In some of the leading cell manufacturers. The other end of that is AI is being using data learnings and machines learnings in the production side, trying to collect data and analysis things that we couldn't find out today.
Yeah.
What we are doing in the middle is after the material but before the production is use that to democratizing battery cell design. Because currently cell design is highly experience, and there are lots of know-hows and it's very random. And we have been using artificial intelligence to conduct optimization of cell designs. There are some limitations, but it started showing some really, really good results after large language models started developing. And what I would say, the benefits from our standpoint, looking the most benefits is combining both data-driven as well as physical model. And if the both of that come together, from our perspective, come out the best result.
Okay. Okay, yeah, thank you for the straightforward answer, and I can only reflect that from my discussions along the expedition. This is an answer I get often from other experts as well, having this two-sided approach. All right, Max.
I work for the company Royma. My name is Gábor Szabó, and yeah, I call it improve the productivity of your gigafactory. We announced it in TraWeBa as getting gray hair from stacking, electrode stacking, and on LinkedIn I posted something with sausages, but in the end you will see everything makes sense, all together makes sense. Royma, as I told you, is a Chinese company found in Suzhou in 2013. At the moment we are over 250 employees, more or less 300 employees already, and very important, over 100 employees in R&D. So we develop and individualize our machines very fast and can do it also for sufficient prices. And we found it in China, and we work together in our construction, our developing of the systems with the battery manufacturers, and very close together with BYD and LG Energy and with 𝗕𝘁𝘁𝗃𝗁𝗃. 𝗕𝘁𝘁 is the most important player. And here you see already the gray hair and the sausages. And the point is, when you stack electrodes, you have a lot of problems. And also when you put all parameters, if you have all parameters in green, you can still have stacking failures from nowhere. And this reminds me on sausages. I worked before in the food industry, 20 years ago in the food industry, and I had a challenge to handle such a package of sausages, like you see it here with a robot. And this was a nightmare because it's very, very soft, and the form is not very stiff, and there's no tension in it and nothing. You cannot really control it. And that's the same with electrodes, because the electrodes are very often very, very soft. So you cannot really grip it or really with an airflow pressure or something handle it. So it's very difficult. And that's why you can get gray hairs if you are responsible for the stacking. And that's why, because you have such a lot of problems with the stacking, you have failures, and that's why you need an inspection after the stacking. The typical points where you look are the overhang analysis. In this case, you see a very proper, very clean overhang. This is okay. You can have a lot of failures after the stacking. It can be folded edges or some crinkle, or you can have a small crash or something which affects the electrodes. Here you see some foreign bodies. So that can happen a lot. That's why, because of the problems also in China and also in Europe, the gigafactories start with an inline 2D inspection after the stacking. The inline 2D inspection looks at the first few very suitable. It's not very expensive. You can place it very easy after the stacking, and you have easy high throughput. But you have with 2D inspection and a high misjudgment rate with a lot of false positives and a lot of missed errors. The second step is that the companies put headline CT beside the lines, which have a much higher accuracy, and then you can analyze very accurately. But with a headline CT, you have no chance to get a high throughput. And that's why Royma developed together with 𝗕𝘁𝘁𝗃𝗁𝗃 our inline 3D CT, which enables a high throughput combined with the high accuracy from the headline CT. And the effect for the productivity is so high that you get within a few months a full return of investment, and you make real money. The only big disadvantage is that you have a bigger footprint than a 2D solution. And here you see it a bit in figures. Here you see the results, the measurement results, if you scan with 2D inspection a good stack and a bad stack. And you see here, anyway, where you put the threshold from the analysis, you have a lot of false positives and a lot of missed errors. And this is really a nightmare. The figures are dramatical, which I got from the customers, now up to 80%. Now here I've wrote only 10% or 10 up to 40%. To be a bit real, or that looks more realistic, but from Northvolt I heard 80% problems. If you use a 3D solution, you have a much more accurate measurement, and if you put the threshold in a zone where you don't accept any missed failures, you have only less than 0.5% false positives. And the figures from China, from the well ramped up productions from cattle, for example, there we got the information that due to the change from 2D to 3D inspection, they increased their productivity about 2%. And that's a lot. And very important, you don't have missed failures. Cattle announced that they don't produce or that they don't deliver a failure rate more than 1 billion cells or something like this. I'm not sure if it is true, but it's very important that you have a good inspection after the stacking. That's already my short introduction, and the call of action is very easy. I'm a salesman, so I can sell you the systems if you like it, and this is clearly the purpose of my appearance here.
Thank you very much, and yeah, maybe let me see you. Thank you very much for the very interesting presentation, and you showed that you are starting now with an office in Hanover. Maybe you could shortly comment what is your strategy or your goal of expanding to Europe, expanding to Germany?
Yes. So we don't expand only to Germany, we expand to Europe. Only Germany would be very overview market at the moment, and we opened the office last year. We are 3 salesperson at the moment, and we have 2 strategies. One strategy is to enable the European customers to get in contact with our 3D inspection technology and buy it for their production in the best way already in the first equipment wave and not after the learning curvature. And the second strategy is that we have also normal laboratory CT, which we offer to the customers, no, for at-line or for end-of-line control, or also other industry, not only battery industry. But the main strategy is to sell this inline inspection for the battery manufacturing.
Hi to all of you. Thank you also, Max, for the invitation. A few words to introduce myself. My name is Rudi Panek. I am working as a senior sales manager at EDAG. And today, as Simon just mentioned, I want to introduce our virtual battery cell production to all of you. And just a few words also to EDAG. We are a very well-established independent engineering service provider. The company has been founded 55 years ago, originally coming from the automotive industry. And through the decades, we have been growing to one of the biggest engineering service providers in the world. And we have also extended our businesses to many other industries, such as the battery industry, for example. We are located currently in over 70 locations with approximately 9,000 employees worldwide. And we are, and this can be seen here in the slide, we are a holistic solution provider, which means that we can support our customers from the initial idea, from the first vision of a product, up to the commissioning and up to the ramp up of the system on site. And as an integrator, we have an holistic and comprehensive approach as well. And we are also accompanying our customers through all key stages in building a battery cell factory. So this can be seen here with a 360-degree approach. The journey usually begins with a feasibility study, is followed by the planning phase, systems engineering phase, up to the ramp up and installation of the equipment within the factory. And as digitalization and virtual planning is essential in our opinion to ensure optimal process reliability, we have created, as Simon already mentioned, a complete metaverse of a battery cell production by using the tool NVIDIA Omniverse. This platform was created by integrating a lot of equipment and component suppliers that you can see on the right-hand side of the slide into the tool in order to display a sustainable and competitive European ecosystem approach. So this is our goal. And we are covering all key stages within the cell manufacturing, from the powder handling at the beginning up to the finished cell. And in this example, it is a 10 gigawatt hour scale. But of course, this approach is completely customizable. It's scalable, and also it improves the planning and layouting significantly because the holistic data concept. And as we all know, the market demands are currently highly volatile. So for us, it's very crucial that the layout as well as the operations are highly flexible and very modular. So what you can see here within the video is that we have developed a virtual reality application. So you can really immersively dive into the factory by using the VR goggles. We have been creating that with the Apple Vision Pro. And as well, a typically overseen detail is the pure amount of material which needs to be transported through the factory seamlessly. So that's why we also have been integrating simulation of material flow. And this is very important in our opinion in this regard. So thank you very much, first of all, for the attention. And finally, I would like to invite you to the EDAG Smart Industry Summit, taking place in Fulda from 17th to 19th of September, with a lot of very exciting partners that we have been including there. We are showcasing several use cases. So this one that we have just seen in the video only as a short snippet will be one of them. And we will also present the latest evolutionary step of the virtual battery cell production on this event. So that will be very exciting. And yeah, so please get in contact with me if you are interested in joining this event. Just let me know and I will send you over the detailed explanation or the detailed information to the event. Thank you.
Yeah, thank you, Rudi. That was an interesting insight that you gave in your pretty much 4 minutes on the spot. If there is no questions from the audience yet, please just consider if you want to ask a question, because I have one that I think everyone may ask themselves now. How is this continue to be developed? What are the next steps in order to bring this really to the market and or like build a new factory with it? What are the next steps that you have ahead of you?
Yeah. This for us is a living project, so it's consistently working on that, and we are still implementing, for example, more and more suppliers. So the platform is growing rapidly. We have already been implementing about 45 to 50 different suppliers, and they are still increasing. So we have several suppliers that are still waiting for implementation. And so this is one thing that we are currently doing. The next thing is that we are integrating much more features to that platform. So for example, it is possible then to integrate and to type in KPIs like CAPEX, OPEX, or the space which is available in your factory. So, and you can also define the output which should be achieved, because this is very much important. And if you then decide if you want to have a CAPEX or OPEX or space optimized planning, the tool is automatically creating your best possible factory that you can get for your requirements and for your specific KPIs. And this is something that we are just implementing into the platform. This will be also shown at the event, the Smart Industry Summit as well. So this is the next step of evolution of the system. And as well, this is the next step is to integrate also the feature that, depending on the KPIs that you have defined, there is a material flow simulation, which is also generated automatically.
Okay. Okay, that sounds quite a computational effort. Is there any? So you do all the computation in-house, or like as a service, or does the customer also need to have anything to deliver to get you operational for a project, a dedicated customized project?
Actually, we only need the 3D data from the suppliers that we can integrate that. And the rest is done by us ourselves with our interdisciplinary teams working on that project. So this is done internally then.
Okay, so it's really just, that was my question, like the step files or like basic CAD files, basically every equipment supplier should have if he builds or she builds a machine. Okay, so then I think everyone that is in the meeting right now, listen up. You can increase your visibility and likelihood of becoming installed in such a factory that is built in the future here in Europe, hopefully, by working together with EDAG, who is also...
Well, hello everybody, and thank you, Max and Simon, first of all, for inviting me. I understand I'm kind of a stranger here in this round, as I'm not a technical person at all. But as Max was introducing me, I'm a lawyer at a law firm that is specialized in product safety and product liability of non-food products. And with that, we also cover the subject batteries, and that's my specialization in this regard. So let me directly get to, can you see everything or do you see?
We see your screen, yes.
Okay, perfect. Because I see myself way in the middle of the screen. Okay, but then it's only from my side. Let me dwell into the subject directly. So the battery regulation is the big thing, regulation from EU that is directly applicable in the member states of the European Union without needing and implementing national legal act. And it's already applicable since the beginning of last year, so 2024. But there are some provisions that will get into force later on. And this is a very, very big step in legal terms, because you can speak of it as product compliance 2.0. We have some big changes now because before the EU battery regulation, batteries in the EU were mainly regulated in terms of waste management, so especially the recycling part. And now within Green Deal from the EU and the Action Plan for Circular Economy, eco-design regulation, that is also was the prime example for the battery regulation, actually. We have now a fully grown regulation for batteries that covers basically everything that we have in terms of product compliance and product regulation in the EU. And this is just to give you a concise overview of the topics, the varying topics that you have. So we have very new things like sustainability requirements. So, for example, there is some carbon footprint that is coming up in the next years as an obligation for battery manufacturers to, first of all, label their batteries with the carbon footprint that they have. And the battery regulation also tells us what the stages are of the life cycle. And spoiler alert, it's the complete life cycle. That's relevant here. Also, there are obligations to get as much, or not as much, but to get different quotes and thresholds of recycled materials, recycled active materials into the batteries. This is also an obligation that will come in the next years. And then we have, besides the sustainability requirements, we have the classic product requirements that you might know from other products, like safety requirements. Of course, every battery that comes into the internal market should be safe. We have a conformity assessment now, and this concludes also with the CE labeling. We now have a QR code that's also coming up in the next years, and ultimately will be the door to get into the battery pass. So a digital product passport, which is a very new system, which will also, from what I understand, manifestly change the data that you have on batteries and how you can recycle them, how is the life health of the battery, etc., etc. We also have our own supply chain system. So this is not to be confused with the CSDDD directive or other supply chain due diligence systems. This is a known system that the EU battery regulation imposes on battery manufacturers. And of course, as before, we have waste management covered as well. So this is the overview as of now. It doesn't look very complex. I understand that. It will be complicated in the next few years. Right now, at the moment, we only have a very few things. Okay, I have the time in mind. We have a very few things that extend the battery regulation. As you can see up there, the battery regulation is the main legal act that's covering the product compliance sphere of batteries in the EU. And this is being supported by other terms, and I just try to make it as concise and understandable as possible what kind of things these are. First and foremost, we have delegated acts and implementing acts, and so far we only have one. That's for the recycling operators mainly, and covering the methods for the calculation and verification of the recycling efficiency. But there are more and more upcoming. So the whole battery regulation has these delegated acts that enable the EU Commission to extend the battery regulation in specific, mostly technical terms. We have also guidelines. By now, there's only one available, which is about the removability and replaceability. Again, that's a sustainability requirement. And of course, I said before, the EU battery regulation is directly applicable in the member states. But there are still national laws needed for some implementing measures, for measures for punishments and fees. For example, if you interfere with the regulation, and this is to be taken into account as well as some formal law, which is a bit ironic because the battery regulation is already applicable, but there are some provisions from the old law, so from a directive that is still in place and will be in place, if I remember correctly, until 2027. So you have to take this old law into account as well. And the last point I want to set, and then I conclude, is the omnibus sphere. This is kind of a new thing, and you might heard of the omnibus rule books that are coming out from the EU Commission, and now covers also the battery regulation. And this does not change the battery regulation that much, but in terms of digitalization it does, and in terms of the applicability of the supply chain due diligence systems. There was a big deal for manufacturers and for all economic operators that are obligated. And since it was apparently not possible either for the manufacturers to implement these provisions, and it was also not possible for the EU Commission to have the guidelines ready to tell the manufacturers, oh, how should we actually implement these provisions that we laid upon? The whole thing got postponed now until 2027, so we have another 2 years, and that's what I wanted to mention as well. And that's already it from my side, just to have a short overview. And if you want to reach out, there's some contact details as well. Thank you very much.
Thank you, Jan, a lot. A bit over time, but I think we still have a couple of minutes for some questions because there are already 2 in the chat. Maybe before I do, I will just read them out. The first one is, what about the impact of PFAS regulations on the battery market? Is there any new timeline for an in-execution date?
Very good question, which I unfortunately cannot answer because I'm not in the chemical compliance. I have a good colleague of mine who is doing these things over and over, day in, day out, and he's the expert on that. This also lets you see how complex these things are. So he's the expert that we have, one of the experts that we have on chemical compliance, and he could answer that. But this brings me to an interesting point. What I showed you was just the battery law. And of course, chemical compliance, just as the REACH regulation, for example, are also applicable right next to that and in parallel. There was
And
the second question.
yes, a question from the audience as well.
So Sak Farouk raises his hand from Rimac.
Yeah, that's me. Firstly, Jan, that's a very good presentation. Appreciate the overview. I rather have, let's say, a high-level question more towards your direction. So I work in a company called Rimac, and we basically produce next-generation battery systems for various European and non-European OEMs and the automotive market in general. So in my capacity, I do have a lot of, let's say, an overview over the European markets and the regulatory laws, as well as non-European ones. And that gives me kind of a comparative basis to also comment. And basically, the question is like, considering recycling, ESG, someone in the audience today asked about PFAS, so prohibited substances, then about renewable energies, and so on and so forth. You know, there's an entire list of such kinds of regulations. Do you think that somehow sets Europe a bit behind in the battery technology race, especially when compared with China, let's say? So yeah, just need your opinion on that. Yeah.
Well, my answer is distinguished in the meantime. When I was starting to get into this topic, I thought so. I thought, yes, it might be a competition disadvantage that we have because we are over-regulating things. Now, and I actually know this from the last TraWeBa Congress in Leipzig where I've been to, that the safety requirements China is establishing are more and more exceeding the safety levels that we have in the EU. And they still seem to manage, the company seem to manage to get these safety requirements in place and to meet the requirements. So I'm not sure as of now if this is really the only problem. What I fear, and this I get also from the battery spotlight from today, is the innovation power. I mean, I saw yesterday or on Tuesday a newsletter from our parliament in Germany stating that they cut back on the research and development funds, the public funds. And this is a very fatal sign, in my opinion, especially in these days, because we need a big focus point on this. And this is also what Simon was saying right at the beginning. To be competitive, we need the money in the right places to make innovation possible, especially in this terms of batteries. So long answer. And by the way, I know your company. I love the Concept 2 car. I never seen it live, unfortunately, and it's way out of my salary range, but it's a nice car. So yeah, that's my answer. So I think it's not just the regulation. I think this can be tackled. This can be done efficiently. But companies are struggling on the financial side, as far as I understand the most at the moment.
Yeah. Thanks for the answer. I think I do agree with you. The hit is more towards the financial side. Yeah. I'll give you an example. Currently, I'm working with quite a large German OEM company producing their next generation batteries, and we have very strict requirements, which are actually EU regulatory directives with regards to recycling, use of materials, which automatically just limits my selection of materials, and sometimes it increases the cost of the overall product. Appreciate the answer, and if you ever come to Zagreb, feel free to ping me. I'll try to get you a track day with the Concept 2 or the Rimac Nevera if I can. Yeah.
Oh, this would be a dream come true. Yeah, thank you very much, Sad. Thank you.
Perfect. Okay, then maybe let me finish this or conclude this with the last question Fritz had, and I kind of have the same question, and you already answered part of it already. And Fritz wants to know, like, that's a lot of regulations. Maybe is it too much? Like, are all these regulations, are actually helping us getting more competitive, or are they actually counteracting that? Only I know it's a long. You can talk a lot about it, but just a really quick answer for that.
It depends, and that's what lawyers always say. It depends. I would say it depends mostly on what kind of provision we're talking about. I see that some provisions on the supply chain obligations just are very hard to implement because you have to go back to the actual resourcing of, for example, lithium. And this is what most companies here in the EU might not be able to do and might not be able to get the information they need from their suppliers. And this is something, there are practical issues involved, and this is the actual hurdle. And this makes it not impossible, but very hard to meet these requirements. For other requirements, for example, the waste management, I would say that's doable because we had that in the last years as well. So that's not entirely new. There are new nuances. And for the sustainability, I think we're talking about batteries, right? So it's the prime technology for the future to have a clean energy provider. And for this, we also need this provider to be sustainable. So it makes sense to have this regulation, to have the sustainability requirements, also to have this regulation, of course. And I would say that's doable and might serve as an advantage, for example, against the US. As far as I know, the US system is mainly, at the moment, it's a bit weird at the moment. It's based mainly on, just get the plants going, whatever. It's not about sustainability. It's also not about safety as much as it should be, actually. But this might be an advantage because at the end of the day, the cleanest product and, of course, the safest product is the product that wins, in my opinion.
Thank you very much. And I actually don't want to cut the discussion short, so we can continue for another couple of minutes afterwards. But I want, because people have to go and have to leave the meeting, so I want to take the opportunity to thank everybody who attended today. I learned a lot. Thank a lot to all the speakers. Very insightful pitches. Most of them on time. I think we now kept our strict time limit in general, so I'm very pleased with this as well. And yeah, I enjoyed this meeting, this event today. We will continue next month on the 18th of September. I put already the link you can use to register for this event or follow the event on LinkedIn. We are also happy if you share the event in your network. So the more people are attending, the more interaction we will get. It would be very great if you could support us in that way. And yes, with this, I think let us continue the discussion, whoever has time for it. Because I think there was still one unanswered question in the chat for you, Jan.
Yeah, I have time. Let me open the chat and I can see it.
So there was the question on. Oh, sorry. Go ahead.
No, I don't have it yet.
It's a lot of regulations that help to get faster in competing or faster in growing from 𝗕𝘁𝘁𝗃𝗁.
That one we covered, but with the next
sorry.
one. How about the fact that the battery passport coming to EU and to sold
that one. Sorry.
in products isn't valid from China imported parts and products? It even got a heart emoji.
Two now. Oh no, just one. To be honest, I don't really understand the question. So the battery passport is coming to you and to all batteries. Of course, imported batteries do fall under the battery regulation as soon as they, let's say, set foot in the EU internal market, unless they're just to go through to another third country, which is not part of the EU. Isn't valid. So I guess he's saying that the passport is not valid for China. imported parts and products, or is he asking this? Because in this case, we have to first distinguish, do we have a battery? Or do we have, for example, a battery management system? And for that, we have to check actually if this very individual product is covered under the battery regulation. Let's say in normal terms, only batteries are covered, of course. So if the product is not a battery, it might not be required to have the battery passport, of course, on that. But even if it's a battery from China, and again, the best battery passport is or the provision is applicable in February 27. So when the provision is in place and we have the delegated acts for that in place as well, then it's also applicable for batteries that come from China. I hope that